So we are now on the fourth question, case study question 4, based on carbons compound. Now you can see some statements are written over here. You have to comprehend the meaning in the exam, or you may pause the video and read it. I'll begin with writing the first question over here. So if I read the first question, well, this is based on a homologous series. So first question is this. Yeah. Okay, what's the question here? It says, which of the following is not the characteristics of homologous series? Right. So first of all, the first property is that homologous series varies in chemical properties. That's wrong. Let me give you an example. Let's say if I take an example of a homologous series, say I take methanol, alcohol. So it is CH3OH, C2H5OH, and C3H7OH, and so on, you can see. Now, what you should remember, the chemical properties of these compounds are conferred by these functional group, right? And the physical property is determined by the carbon chain. This is what you should know. So as we can see that this is not a correct. Now, if I read the next part, it says the physical properties vary in regular and predictable manner. Physical properties, uh, right? What we have to do is not a characteristics, right? So that means I just figured out that we have to check for the one which is, well, the statement is incorrect. The statement is incorrect, but we have to choose which is not not a characteristic. So anyway, this answer is, this part is, as for the option, it is correct. But let me figure out the other options also. Their physical properties vary in regular, predictable manner. That is true. As we go down in a functional group, its melting point and boiling point increases and its solubility decreases. So it's predictable. We should say that there's a gradation in the physical properties as you go down. So the second one is a correct statement over here. The third, if I read, it says the formula. The third is what? The formula fit the general molecular formula. That's true. Let's say, for example, for this is an alcohol homologous series. Its general formula is what? CnH 2n plus 1 OH. Now you can even verify this, right, by placing different values of n. So they follow a general formula. So this is correct statement. Now, the adjacent members differ by 1 carbon and 2 hydrogen atom. You can figure out. Let's say this one is varying from its preceding as well as succeeding member by CH2. You can check it. If you get the difference of carbon and hydrogen, you check that you are getting difference of how many? 1 carbon and 2 hydrogen. So that is CH2. So this is a correct statement, but then we have to look for the incorrect statement, and the incorrect statement, as we have already figured out, that this is an incorrect statement. So this is what we have to do. Now we have done the first one. I'll come up with the next question over here. So if I type the next question here only, what is it? The second part, not the next question. The second part says all the members of the homologous series of alkynes have the general formula. So alkyne is what? You should know alkyne is this, right? YNE. Check here. This is incorrect. This is for alkane, right? The second one is for alkanes, and this is for alkynes. So we just have to figure out the correct answer, and this is for alkynes, right? YNE. So the correct answer is option C in this case. Now let's check what is the third question here. So if I check for the third question, third is this. It's a big one. Okay, let's see. So which of the following statement is not correct? Again, not is the question here. So a common functional group is present in different members of homologous series. How can this be? You know that like in functional group, alcohol, it is OH, right? OH. In aldehyde, it is CHO. In carboxylic acid, it is COOH. In ketone, it is C double bond O, right? CO we say. So obviously different functional group, right? This is same, right? A common functional group is present in different members of. Okay, okay. Let's say I read it wrong. Let's once again read it. Rectify, rectify. The question is a common functional group is present in the homologous series. Yes, this is correct statement. As you know that once again, if I write the same functional group, say alcohol, it is CH3OH, then C2H5OH. This is a homologous series, right? C3H7OH. As you can see that the same functional group is present throughout this homologous series. So this is a correct statement, but then we have to look for incorrect. Now the next one is that two consecutive members in homologous series by differ by CH3. No, we just answered this part, right? They vary by CH2. Each member varies from its succeeding or preceding member by CH2 group. Now, although we got the correct answer here, but let's read it, the other options also. You see the molecular mass of the compound differ by 14 a.m.u from its neighboring. We just figured out that it is CH2. The difference is CH2. So let's verify it. Carbon whose molecular mass is 12 and hydrogen whose molecular mass is 1. So 1 into 2 is 2. So it comes out to be 14 U. U stands for, it can be now we use U for unified mass, not atomic mass unit. But anyway, the answer is correct. So this is a correct option, but we were looking for the incorrect. I'll read the last option also. All the members of the homologous series have a common general methods of preparation. It should be they have common chemical properties and a common method. So a statement are correct here, but since we were looking for the incorrect options, and incorrect, which is not correct, is option B. Now I can do the next one here only. Say if I erase this and typing the fourth part. Fourth part is what? Again, many options here. So identify the correct statement. This time it is correct. As the molecular mass increases in any homologous series, the gradation in physical properties seen. Already discussed. But then I should once again write down, this is CH3, same functional group I'm taking because I can find that it is easier and less time taking. C2H5OH and C3H7OH, right? So there is a gradation in the physical properties. As you know, it is a correct statement. And the reason is the molecule, as the molecular mass increases in any homologous series, there is a gradation in physical properties. And you should also know that there is another reason why the chemical properties, melting point and boiling point increases as we go down a group. The reason is very simple, that you can figure out. As you go down a group, you are finding that more bonds are there. Therefore, greater energy is needed to break this bond. Now, if I read the next part, the other physical properties such as solubility in a particular solvent decreases. This is a correct statement. Okay, we can see that we have to check for more than one correct. So let's this be correct. Yeah, you should also know that as we go down in a group, the solubility decreases. That means methanol is more soluble than ethanol, and ethanol is more soluble than propanol. Checking for the next part. So other physical properties, solubility in a particular solvent decreases. So it's incorrect, right? It's a correct statement, right? Because as I said, solubility decreases. All right, the D part is what? D part is the chemical properties which are determined solely by the functional group and remain same in the homologous series. Now, what do you know that about this chemical properties? Chemical properties are determined by this functional group. Chemical properties which are determined solely by the functional group remain similar in homologous. Yes, they all will have similar chemical properties as they are all belongs to the same functional group. So these are the correct. The options here is A, C, and D. Okay, over here I've written in a different manner. A stands for first, third, and fourth. First, third, and fourth. Yeah, check this one. So this is the correct answer for this question. Now I think I'm left with one more part for this. There are 5 parts. The fifth part is, okay. So we have this as the fifth part. So the question says the table is shown over here. Three organic compounds belong to the same homologous. So this is three organic compounds having same homologous series. The first member of the homologous series, second member of the homologous series. Now question is what? I can see first, what is the general formula of this series? Okay, for that what you can check here. The options given over here. All of them has one carbon, one oxygen, not one carbon, one oxygen, right? So all of them have, so this I'll discard. All of them has one oxygen. Let's figure out. If I place over here, as you can see in the first case there are how many? Two carbon. So let's plug in NS2, and what we are getting H from here, 2 times 2, that is 4, and O. Check, is it correct? No, it's not correct. As you can see over here, if you count, there are 3 plus 3, 6. So first is incorrect. Now, if I place this on the second, this is Cn H2n plus 2 plus O. So check here, placing N as 3, I'm getting H 3 into 2, 6 plus 2. No, there are two carbons. Sorry. Two carbon. Here, yeah, there are two carbon. So hydrogen is how much? 2 twos are 4, 4 plus 2 twos are 4, 4, 4 plus 2, 6, and O. C2H6. When I do back counting, let's see, C2H6O. This is correct, but I need to verify for the other parts also. I'm going to verify this one. So if I plug in here, what I am getting, carbon is 3, so 3 carbon, 1, 2, 3. And hydrogen, how much we'll get? Placing NS3, 3 into 2, 6, 6 plus 2, 8, and O. I'll do the back counting, 3, 3, 6, 7, 8, and O. Yeah, this is correct. So you'll say that this option is correct. So we will not go for the other option in this case.